Hello, this is Elizabeth from the Academic Support Center at Raritan Valley Community College. This is a little video on radical expressions and functions. So radical expression comes from something like this. We have b squared is equal to a. That means that b is the square root of a, and we write that as b is equal to the square root of a. Okay. The square root of every positive number has two two answers. So if we take the square root of 25, this can equal positive 5 because 5 times 5 is 25, or it can equal negative 5 because negative 5 times negative 5 is 25. When we have this radical expression, we always take the positive. The positive is called the principal square root, and when we see just this radical expression like this, we're looking for the positive function. And again, what we're looking for is what number times itself, or what number squared, will give us the number under the square root symbol. So we can do a couple of examples. If we said the square root of 16, what times itself gives us 16? So that's 4. We can take the square root of 0.25. What times itself gives us 0.25? That's 0.5. 0.5 times 0.5 is 25, and then we move the decimal 2 places to get there. We can also take the square root of a rational function. So we have the square root of 9 over 16. Well, we can take the square root of 9. What times itself gives us 9? That's 3. And what times itself gives us 16? That's 4. Okay. One other thing I want to say just about square roots is that you cannot take the square root of a negative number. No matter what, if you multiply, if you square a number, it's always going to be positive. So the square root of a negative number is not a real number. Okay. Likewise, we can take just like the square roots, we can take the cube root. So we can take the cubed root, and that is b to the third is equal to a, or b is equal to the cubed, oops, kind of messy, the cubed root of a. Okay. Unlike the square roots, we can take the cubed root of a negative number. And again, the cube root is asking us what to the third power will give it, or what cubed gives us that number. So if we looked at the cubed root of 8, we want to know what times what gives us 8. So this is 2 times 2 times 2 is equal to 8. So the cubed root of 8, I guess I don't want this equal sign here. I just want to write this over here. So the cubed root of 8 is equal to 2. And like I said before, we can take the cubed root of a negative number. So we can take the cubed root of negative 27. Okay, so negative 27 is negative 3 times negative 3 times negative 3 is equal to negative 27. So the cubed root of negative 27 is equal to negative 3. Okay, so in general, we can take the nth root of a number. So we can say, we can take the nth root of a is equal to b. And this means b to the n is equal to a. Okay? So if n is even, then a has to be a positive number. Just like we can't take the square root of a negative number, we can't take an even root of a negative number. Okay? If a is negative and n is odd, then we're always going to get a negative number. Just like here we had the cube root of a negative number, we got that was negative 3. The cube root of a positive number is always going to be a positive number. Okay, so when you take the odd root of a negative number, you get a negative number. take the odd root of an even number, of a positive number, you get a positive number. Okay? If you take the even root of a negative number, that is never a real number. Just like the square root of negative 25 doesn't work, because the question is what squared gets you 25? Well, negative 25. Nothing squared is ever going to give you a negative number. Okay? And if we have a number, if we have the square root of x squared, this is always going to equal the absolute value of x. Okay, so we square x. If it was a negative number, we're going to get a positive number. And if we take the principal square root, we're going to get the positive number. So let me show you what I mean. If I have negative 3 squared, the square root of negative 3 squared, well, this is equal to the square root of 9. And the principal square root of 9 is 3. The absolute value of negative 3 is equal to 3. So when we square it, we get the rid of the negative sign. When we take the square root, we get the absolute value back again. Okay. So I wanted to go through just a couple more examples of these things. So we have, let's see, let's just go through. I have a couple written down. We have the cubed root of negative 125. Okay, so we want to know what cubed gives us negative 125. It is worthwhile to write, set out a table where like 1 x squared, x cubed, x to the 4th. If we have x is equal to 1, this is 1, 1, 1. If we have x is equal to 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16. We have 3, 3 squared is 9, 3 to the 3rd is 27, 3 to the 4th is 9 times 9, which is 81. It's useful to have these in the back of your mind. 4 is 16, 64. I don't know what that next one is. 5, if we have, if we have 5, 5 squared is 25, and 25 times 5 is 125. Okay, it's useful to know these. These are math facts that are basic, but like writing them down and thinking of it this way really helps when you start looking at these cubed root. So x cubed is equal to negative 125. Well, 5 cubed is equal to 125. So this is going to be negative 5. What else? The 4th root of 16. So what times itself 4 times gives us 16? If we look at this table, that's 2. 2 to the 4th is 16. The other way we can look at this is 16 is 4 times 4, which is 2 times 2, 2 times 2. So this is the 4th root of 2 to the 4th, which is equal to 2. Okay, so whether you memorize this sort of information or if you do a prime factorization, however you get to that, the question remains, what to the 4th is going to give us 16, and that is 2. If I have the 6th root of x to the 6th, just like with my square root, I get the absolute value back. With my even roots, if I'm taking the 6th root of x to the 6th, I'm going to get the absolute value of x back. However, if I take the cubed root of z to the cubed, this is just going to give me z back. Because if z was negative, when we cube it, we get a negative number. And when we take the cubed root, we get a negative number. So with our odd roots, we get that number back. With our even power and roots, we get the absolute value back. And the last one of these was just the square root. We can have, it doesn't just have to be an x under here. It can be more of a function. And we're just going to say that this is equal to absolute value of x plus 2. So when we take the square root of something squared, we get the absolute value back. And this can be more than just a number in here. This can be a function. Okay, and the very last one I wanted to take a look at was actually applying this as functions. So if we have, there's some problems like this in your book, f of x is equal to the cubed root of 5x minus 2, and we say x is equal to negative 5 and 2, we're going to plug these numbers in. So f of negative 5, just like with any other function that we've seen, we do 5 times negative 5 minus 2. Well, 5 times negative 5 is negative 25. So this is the cubed root of negative 27. And now again, back to our chart, or if you do a prime factorization, either way you get this is negative 3. And then we want to do f of 2. Likewise, we're just going to plug 2 in for x. So this is 5 times 2 minus 2. This is the cubed root. 5 times 2 is 10 minus 2. Sorry. 10 minus 2 is 8, so this is the cubed root of 8. Cubed root of 8, 2 times 2 times 2 is 8, so the cubed root of 8 is 2. Okay? If you have questions with this section, please feel free to reach out, or actually any section in your math, but this one in particular, please reach out to the Academic Support Center. We're here to help.